Okay, dear students, welcome back. So, today let us discuss about Fourier series of odd functions. And Fourier series of even functions we will discuss in a separate video. Okay, now just a quick recap. What is an even function? What is an odd function? If you remember, if suppose a function is, let us say, x square, okay, and this function is defined on some interval, something minus p2 plus p, okay. So what will be f of minus x? If you see, when you replace this x by minus x, what will you get? Minus x whole square, that is again as x square, right? So what we have observed, that for this function fx and f of minus x both are equal. So these type of functions, they are called as even functions. Okay. And same way, if we have, suppose, fx is equal to x power 3, let's take, defined on some interval minus p to plus p. Now what will happen if I replace x by minus x? This will become minus x whole power 3, which is nothing but minus of x cube, right? So what are we seeing? That fx and f minus x are same? No. What is happening? F of x and f of minus x have the same magnitude, but the sign is opposite, right? So if fx and f minus x both are equal, then the function will be called as even function. And if fx and f of minus x, they both have same magnitude but opposite sign, this thing gives us the concept of odd functions. Okay, so this type of functions are called as odd. Okay, so I hope the difference is very clear. This is basically a school level concept you have already studied in your schools. Okay, so there is nothing much to go into detail. So let us take one odd function and let us find its Fourier series. Okay, but before that, why we need special emphasis on the Fourier series of odd functions, Fourier series of even functions? Why we have to discuss them separately. Anything special with them? Yes. Remember, when you are finding Fourier series, the formula is A naught divided by 2 plus summation an cosine n pi x by 2 n pi x by L plus summation Bn, same thing with a sine. Here you have taken cosine, now you will take sine. Sine n pi x divided by L. Okay, this is the formula for Fourier series. And A naught is given as 1 by L integral from A to B fx dx. An is given as 1 by L integral A to B fx cosine n pi x by L dx, and Bn is equal to 1 by L integral A to B fx, and same thing with the sine. Sine n pi x divided by L. Okay, and if you remember that here L value is given as B minus A divided by 2. From where this B and A are coming, this is the interval where the function is defined. Okay, like you are finding the Fourier series of some function fx which is defined on the interval A to B. Okay, so this is the formulas required for finding the Fourier series. Okay, now what is special? What we are doing today, what is special in this? We are discussing even functions, odd functions. We are finding the Fourier series of even functions separately. We are discussing the Fourier series of odd functions separately. Why? The reason is that if the function is odd function, in this case A naught and An both will be equal to 0. So your job will be only to find the value of Bn. Okay, so your work will be reduced. There is no need to waste time on finding A naught and An, because the moment you see that my function is an odd function, directly I will write that okay, I don't need to find A naught, I don't need to find An, because both of them will be equal to 0. Directly I can write. Only I have to find the value of Bn, right? So my work is reduced. Same way for even functions. If I know that my function is an even function, in this case, my Bn will always be equal to 0. Okay, so what we have to find? We will have to find A naught and we will have to find An. Okay, so again our work will be reduced because we don't need to find Bn. We will directly write that Bn will be equal to 0. Is it okay? So now let us take a simple question and try to understand how we find the Fourier series of odd functions. So let us take the simplest example, which is find the Fourier series of the function fx is equal to, let's take x, and let us say it is defined from minus pi to pi. Okay. The moment I see that I am discussing about fx is equal to x, and the interval is also of my preferred type, when we want to check whether the function is even function or odd function, we always consider that the interval should be of this type, from some minus p to p, right? So here also this looks good, minus pi to plus pi. Okay, and the function is fx is equal to x. This is also fine. So fx is x. So if I replace x by minus x, so my f of minus x will be equal to minus x, right? So I can see that both these functions have the same magnitude, but the sign is opposite. So I can conclude that yes, this given function fx is equal to x is an odd function, right? Because it satisfies the definition of odd function. Okay, so the moment I observe that this function is an odd function, I will immediately write one line. Therefore, a naught will be 0 and a n will also be equal to 0. So both these coefficients, a naught and a n, both will be equal to 0. Okay, so what I need to find? Only we need to calculate the value of bn, right? Let us write the formula first and then we will move ahead. Okay, now somewhere in the corner let us find L. Okay, how we define L? B minus a divided by 2, right? What is my B here? B is pi, right? Minus a, what is my a? Minus pi, isn't it? Divided by 2. So this will give us pi plus pi, that will be 2 pi. 2 pi divided by 2 will remain pi, right? So L is equal to b minus a divided by 2. B is the end point of my interval and a is the starting point of the interval, right? Okay, so in this question L is equal to pi. Okay, no problem. Let us continue. What is the formula? Formula is 1 over L. What is my L? Pi. Integration a to b, right? A to b. A, the initial point of the interval, that is minus pi. B, that is the upper limit of the integral, which is the end point of the interval, that is pi, right? Fx, which is equal to x, multiplied by sine n pi x divided by L, that is again pi, and integration with respect to dx. So what will happen? In simple terms, this will become 1 over pi integral minus pi to pi x sine n x dx, because here what will happen, this pi will get cancelled with this pi, right? Okay, so before we put the values, let us integrate first. So integration, this is integration by parts. Whichever method you find easy, whichever way you find easy, you know how to integrate. Okay, you can also use this shortcut technique, because here one of the functions is a polynomial function. So you can always use this technique, which is a shortcut technique. It saves our time also, right? So the first function you will differentiate and the second function you will integrate, and we continue till we get 0 in the derivative part, right? So derivative of x will be 1, and integration of sine nx will be cosine nx with a minus, right, divided by n. Okay, then derivative of 1 will become 0, and integration of minus cos nx divided by n will give us minus integration of cosine will be sine, right? So sine nx divided by n, and one more n is already present, so it will become n square, right? So then what we do, we multiply like this. X will be multiplied by minus cosine nx by n, and 1 will be multiplied by minus sine nx over n square. And when you write it, this will become 1 over pi integral minus pi to pi. So let us multiply now. So x cosine nx divided by n with a minus sign, and the second part will become minus 1 into sine nx over n square. And remember that in the second step, or you can say in the alternate steps, we change the sign. Okay, so if we are getting minus here, we will take it as plus. Is it okay? So okay, here there is a writing mistake, so this will be the integration. Okay, and we have the limits minus pi to plus pi. Okay, now let us put the limits and let us see what we get. Okay, so this will become 1 over pi. Now let us put x equal to pi first. So we get minus pi cosine n pi divided by n plus sine n pi over n square. This is the first part. Minus, now we will put x equal to minus pi. So what we get? Minus of x, that is minus pi cosine n times minus pi. So we can say cosine n pi minus, is it okay? Divided by n minus, sorry, plus sine nx. Again, this is minus pi. You can say minus n pi divided by n square. So this is what we are getting after putting the limits. Okay, so if you check sine n pi, this will become 0, and sine of minus n pi, this part will also become 0. And there is a property of cosine that cosine of minus theta is same as cosine theta, right? So after using all these things, what we get now? 1 over pi minus pi cos n pi divided by n, right? And if you see here, this will become plus pi, okay? And one more minus is there, so it will become minus, right? So minus pi. Here if you see, cosine minus n pi, using this property which we have written just now, cosine minus pi will be same as cosine n pi, right? Divided by n. So finally, we are getting 1 over pi cosine n pi divided by n, minus and both are same, so that will become 2 times, right? And if you observe, this pi will get cancelled with the pi outside the bracket, right? So finally we are left with minus 2 by n cosine n pi. And if you remember the formula, minus 2 by n, and cosine n pi is equal to minus 1 to the power n. So finally you have got the value of the Fourier coefficient. Okay, so we wanted to find the value of Bn, and we have got the value of Bn, minus 2 by n multiplied by minus 1 power n. So this is what we required, and now we are in a position to write the Fourier series. Therefore, the Fourier series is fx is equal to a naught divided by 2, that part will become 0, summation a n cosine n pi x divided by L, that part also will become 0, so we don't need to write that at all. Okay, so only we have to write the part which contains Bn. So that will be summation Bn, which you have calculated as minus 2 over n minus 1 to the power n, with sine n pi x divided by L. In this question, L is equal to pi, right? which you observed here. Okay, so if you want to cancel these two pi's here itself, that is also fine. So this is your Fourier series which you were searching for. So this is one question which we have discussed on Fourier series of an odd function. You can try to find the Fourier series of the function fx is equal to x power 3. And you can consider the same interval, no problem. You can treat this question as your homework. Exactly same steps you can follow. You know fx is equal to x power 3 is an odd function, and the interval is also of the type minus p to plus p. So this is an odd function. We are finding the Fourier series of an odd function. It means a naught and an both will be 0. So you can try to find the value of bn, and finally you can write the Fourier series also. So I advise you to try this question at home. Okay, so this is all for this video, and in the next video I will discuss one question on how to find the Fourier series of an even function. So we will meet very soon in the next video. So till that time, take care all of you. Goodbye.